Hello, algebra scholars. I'm going to kind of walk you through how to do the comparative statistics project. So the centerpiece of the project is going to be looking at data sets that compare two sets of related data. So you're going to be answering questions like, are Fords faster than Chevys? Or does the north side or the south side of Indy have a better price for gas? So when you're doing this, you can either create a poster or a PowerPoint, or if you really feel in the mood, you could even create a video using the record feature of Zoom, kind of like what I'm doing right now. And the first thing you want to talk about is explain how the data was collected. Then you want to be showing me some of your computations for your spreads and things like the central tendency measures too, like means, medians, and modes. And then use your computations and summary statistics to answer the question. So you could say, like, since the mean of this car company acceleration is lower than the mean of this car company's acceleration, then maybe this car company has a faster acceleration. And if your answer is depends or unknown, make sure that you use your data to justify it. And you should also have good quality visuals as well. You know, things like those box and whisker plots, where you had with like kind of a good number line as well to show where you're at numerically. And even like comparative tables as well. So you could have like the means and the medians and the modes side by side. So I'm going to kind of run us through a sample exercise here and kind of give you some ideas about what you should be doing with your own data sets. So we're going to look at the Chevy versus Toyota reliability. So where this comes from is a magazine called Consumer Reports. So Consumer Reports tests cars, but they also survey consumers about whether they have problems in their vehicle or not. So somebody may have like a Toyota Camry and they fill out a survey about whether they've had problems with that Toyota Camry. So vehicles then, after the surveys are turned in, they get a score from 0 to 100. So 0 means the least reliable car, 100 is the most reliable car, and a 50 is a car that's kind of like average reliability. One of the first things that you should do when you are first looking at your data set is you should be ordering your data from least to greatest. So in the case of the Chevy, we have two cars that have a rating of 2. Then we have 11, 13. Next up, we got 29, 2 34s. There's also a 27 that I forgot in there as well. And let's make this wider. We got 49. And then there's actually some Chevrolets that are more reliable than the average car. Including the Chevrolet that got a perfect reliability of 100. Let's make sure we have the 13 data sets. Yep. And then we're just going to find, I like to find the median. So I'm just going to kind of put dots until I find the median. And this is an odd number of data. So right there is the perfect median. And then we're going to kind of look at the bottom half to find our Q1. And we can kind of see in the bottom half that the middle two data, since we kind of have that even number of data between 11 and 13. So our Q1 is 12. And then we have a 58 and a 75 in the middle for our Q3. So we have to average those two. So if I just do 58 plus 75 divided by 2, that will get me my Q3. So that's going to be 66 and a half. All right, and then we have the Toyota. We can kind of take a look at that. So I'm going to kind of put the data in order again from least to greatest. So just because something's a Toyota does not mean it's always going to be super reliable. They have a model that actually rates a 27 out of 100. So I'm going to put that in order from least to greatest. So I got 27, 44, 45, 55, 67, 70, and we'll make sure this is nice and wide, 71, 2 cars with the 75, and then an 86 and a 91. And a 92. So I'll make sure I got 12 in there, which I do. So then I'm going to kind of look for that middle number first. So like if I do 1 on one side, I do 1 on the other until we meet in the middle. And actually there's 2 that are left in the middle because you do want the same number. So the median is going to be 70.5. And then if we want the Q1, we include up to the 70. So we kind of include, you know, the bottom 6 pieces of data here, which I noticed that right between, so I got 45 and 55 in the middle. So my Q1 is going to be 50. And then I'm going to look at the 71 to 92 on the other half. So my Q3 is going to be 75 plus 86 over 2. And I'm just going to divide by 2. So I'm going to get 80.5. So we got some raw computations here, which is good. So now we want to actually kind of look side by side and offer a sort of comparison. So one way to kind of compare is just have a table of like all the data points. One thing we did not compute that you should compute is the means. It's especially nice to kind of compare them as they relate to the median, especially accommodating for those spread of data. But we got for the Chevrolet that the median was 34 versus a Toyota had a median reliability of 70.5. And then the mode, you could have two modes for a Chevrolet. So there were two that had a reliability of 2, and then there were two cars with a reliability of 34, and then the Toyota had a mode of 75. And then the range was kind of like your high value minus your low value. So we went from 100 down to 2 for our reliability on our Chevrolet. So that's a whopping 98. And then for the Toyota, we went from like 92 minus 27. So that gets us to 65. And then our IQR is just Q3 minus Q1. And we computed those. So for the Chevrolet, the Q3 was 66.5 minus 12. So that's a 54.5. And then the Toyota, on the other hand, would be 80.5 minus 50. Which happens to be 30.5. So a few observations here. The median Toyota is more reliable than the median Chevy. Now, this does not mean that all Chevys are unreliable. You know, there's that Chevy that has a reliability rating of 100. That's actually more reliable than any Toyota out there. But, you know, when we're kind of looking at the middle, that middle Toyota is going to be more reliable than that middle Chevy. We can also see that Toyotas are more consistent in reliability, since the ranges and the IQRs are smaller. So having like all these statistics and stuff is great, and verbal descriptions are showing that you're kind of analyzing them well, but having a good quality table is going to be really helpful, and having a box and whisker plot is going to be even more helpful. So you may want to have 0 to 100. You should be having a title called CR reliability score. So this tells us what we are comparing and what we are measuring. And I would say every 10 or every 25 would be fine to capture the relationships. And we'll go in color here. So maybe for Toyota, we will go green. No, we'll go, yeah, green. Toyota makes lots of hybrids. So the median reliability for a Toyota is about 70.5, and the Q3 is about 80.5. and the Q1 would be 50 exactly. And then we just kind of extend the whiskers to be like the maximums and the minimums. So there's Toyota. And then we might look at Chevrolet. So maybe for Chevy, we'll do a blue. And we see that the minimum is like a pathetic 2, but their average median reliability is down at a 34. It's not very good. And the Q3 was like a 66.5. And the Q1 is down like at a 12. And then the maximum reliability is 100. And the minimum reliability is a 2. So now we can kind of see side by side that most Chevys, are kind of in, that blue rectangle, the blue box. And while most Toyotas are in the green box, and we can see that most Chevys are worse than Toyotas. But there is kind of a more wider spread, so to speak, in the Chevy. So you're going to kind of be doing your own data and kind of choosing, one of the 5 different choices. And I hope that you kind of use these tools to really paint the picture and analyze the data.